All right, so probability. There's only 4 exercises that we're looking at. It is 8G to 8J. Last session, I showed you how to find the probability of one single experiment, and then you had one where it was 2 experiments, right? That was 8H. When you get and most of these questions here, you don't actually need the diagrams to help, but for a lot of us, having a diagram helps you to solve the problem. So you don't have to, but it does help for those who find intuition a bit harder to do, yeah? So I like diagrams. I'm a visual learner, so I draw the diagrams quite a bit. But here's a problem for you to sort of visualize. Let's say I gave you a spinner, right? It has the number 1, 2, and 3. Shh. Thanks, team. Don't speak while I'm speaking. When you spin this, there is obviously, let's say, there's a little tab that lands on either 1, 2, or 3. So when you spin it once, the first time you spin it, this is an easy one to calculate. On a logical sense, we know that the probability of getting a 2 if we spin it once is what? 1 out of 3, because there are 3 options. And for the tab to land on 2, well, there's only 1 2 there, so it's 1 out of the 3 options. So we say probability, so I'm going to remind you of what we did last week. PR, capital P, for the chances of the probability of. Make sure to use the brackets because you're going to tell the event. And what is our event in this particular case? The probability of? What do you write in that little space there? 2, because the event is getting a 2. So mathematicians, we're too lazy to write probability of getting a 2 if we spin the wheel is, if you've got the context and you write PR bracket 2, people will understand that you're saying that. Equals, and Attila said it was 1 out of 3, which is correct. Okay? The challenge now makes it a bit different. That if I said, well, what if I spun it 3 times now? So I spun it once, and I spun it twice, and I spun it 3 times. And I want to ask, what is the probability of getting all 2s? So getting a 2 on the first go, 2 on the second go, 2 on the third go. Now, for some of us, you might already got the answer, and then maybe a middle of you, average group of you might be like, oh, I can kind of figure it out if I have a think a bit. And then some of you might be like, I have no idea how to figure it out. Yeah? This is where a diagram will take most of you to a direction where you can solve that problem. Okay, so there's a bit of intuition. Some of you got the intuition already. The intuition is that you said the first time is a third of a chance. So you got 33% chance of getting it the first time. Then if you spin it the second time, again, you still have 33% chance of the 33% chance. So it's a third of the third. And then if you spin it the third time, it's a third, 33% chance of the 33% chance of the 33% chance of getting all 2s. See, that's the intuition that when I read it, that's what I see. But we know of. What does of mean again? Add, subtract, multiply, divide. Which one is it? Multiply. So logically, for me, I already understand it's 1/3 times 1/3 times 1/3. And I know the answer is 1 out of 27, right? But not all of us will have got that answer just from reading that and logically. So I'm going to show you in a diagram why tree diagrams can be useful so you can visualize how I got to the answer. And that answer is not always true if it was a biased spinner. If it's not a fair spinner, the answers won't be 1 out of 27 because it's not fair, right? So let's draw it. Let's see how a tree diagram can make you visualize how I got the answer 1 on 27. If I spin it the first time, what are my options again? What's my sample space? 1, 2, and 3. So first spin, this is why we use a tree diagram. We're saying, all right, starting at the first point, when I spin it, I have 3 options. You can either get 1, 2, or 3. So in a visual aspect, that makes sense. This is your first spin. So I'll write first spin up here. First spin. You could have got a 1, could have got a 2, could have got a 3. We have no idea. But then, after you got your first spin, you do it the second time. Now the second time, you still have 3 options. So it'll be another 1, 2, or 3. So you could end up with, so far, you either have a 1, 1, 1, 2, or 1, 3. You might have had, if you spun it 2 times so far, you could also have gotten a 2 on the first go, a 1 on the second, or a 2 on the second, or 3 on the second. But I'm hoping that you're starting to see a pattern. First go, how many options did you have? How many options did you guys have when you first spun it? 3. So that's why Attila said it was 1 out of 3, right? But when you spin it 2 times, how many options in total do you have? So you could have got a 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So what's the total amount of options there? 9. I'm hearing.
Please excuse this interruption. Could the owner of a red MG, Retro 1VJ 7LI, please report to the General Office? The owner of a red MG 1VJ 7LI, please report to the General Office. Thank you.
All right, let's recollect again. So some of you said 12, and I'm interested in this final line. Remember, you can get 1, 1, 1, 2, 1, 3, let's count them. That's 1, 1, that's one option. You could get a 1 on the first go, 2 on the second. That's 2 options, 3 options, 4 options. So what's the total options? 9, because there's 3 plus 3 plus 3. But what you should also notice here is that for every option, you have 3 options. So that means 3 groups for every option you have here. So 3 times this one, that's 1, 3. 3 times this one option, you get another 3. 3 times this one option, you get 3. So really, how did you get 9? It was the result of actually having 3 groups of 3. Yeah, 3 times 3, that's how you got 9, because there's 3 options for the first one, 3 options for the second one, so 3 by 3 gives you a total of 9. Now, using that logic, without drawing the next one, how many options do you think I would have if I actually spun it 3 times? If I spun it, so the third time I could have got 1, 1, 1, and then 1, 2, 3 again. So it's 1, 2, 3. But let's just look at the pattern. How many total options do you think end up here? What was that? 27. There's 27. And this is what I mean. It's not intuitive for some people, but the diagram will help you. See, a diagram would say, well, there's 3 for every one option here, but there's 3 options there. So 3 times 3 here gives you 9. But then for every 9 options, there's another 3 options here. So it's 9 by 3 again. So 9 times 3 gives you 27. Now you can draw the diagram, but you couldn't understand what I was trying to say. For some of us, we might actually have to draw the full diagram. Then you can see the full 27 options. Because if you actually sat down and wrote the sample space, it would have looked something like this. 1, 1, 1, 1, 1, 2, 1, 1, 3, and then 1, 2, 1, 1, 2, 2, 1, 2, 3, and you can do that. That's what I meant, that the middle group, intuitively, you would be able to come up with that solution eventually. Eventually, I would have asked you, what's the chances of getting all 2s? Means, what's the chances of getting 2, 2, and then another 2? You'll notice there's only 1 out of, and you just need to figure out the total. So that middle group, we'll be able to figure it out intuitively, even without the diagram. You could still have done this, and you organize it in a way, logically, you would have figured out the answer. And then there's groups who would have gave up because they couldn't be bothered thinking that far, right? The diagram is what we're trying to teach you, to give you a structured way so that instead of writing it 1, 1, 1, 1, 2, 1, 1, 3, takes too long. I didn't have to write that. I just looked at it and I could say, yep, there are 27 options in total. So probability of getting a 2, 2, and a 2, I know there are 27 possible options to begin with. And that's because I know for every 3, there's another 3 here. And every 3 here, there's another 3 there. So 3 groups by 3 groups by 3 groups gives me 27 options in total. And the diagram is very obvious in that sense. Yeah? So it's out of 27. And how many of those will I have a 2, 2, 2? There's only one way of getting 2, 2, 2. There's no other way that you can get that. So that's why we know it's 1 out of 27. But this is the exercise that they're trying to train you to do. They're trying to train you to have a skill and option why these visual diagrams can help you. You don't need it, but it's helpful. Yeah? So the answer is 1 out of 27. I got it through intuition that it's a 33% chance of a 33% chance of a 33% chance. Logically, you're just doing 33% of 33% of 33%. This is like a third times a third times a third. That's why I know it's 127. The only reason this is going to work again is if it's a fair dice or a fair spinner. If it's not fair, that's not true. Okay? All right. Let's do one example. Let's see if you can have a go at the thinking here, okay? Yeah. Yeah, sure. So let's say you got a coin now. You got a coin and it's tossed 3 times. So again, you know, if I flipped it once, you would have said chance of getting tails is half, right? But now I'm asking, what if you had a coin and you flipped it 3 times? Well, this is what you're going to get. First go. How many options do you have? Heads or tails. So you write heads or tails. That's your first go. Now notice the pattern again. There's 2 options for the first go. If you flip it the second time, you could get another 2 options. How many total? How many in total? 4. And again, it's for every option you have before, there's an extra 2. So it's 2 groups for every 2. So 2 times 2 gives you 4. And we can see that in the diagram that it makes sense. You get HH, HT, TH, TT. But if I did it 3 times now, the diagram will show you, let's think, I'm not going to draw it fully, but I want you to think about the total options here. So again, you could have H, T. So you could have got, in 3 goes, you could have got H, 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 T. Now we follow that pattern, you can draw it all out, but what's the total number of options that I would get? What's the number of options would I get in total? Have a think. What would the answer be? How many total options are there? Let's go with Charlie. How many do you think would we end up with? Yeah, and what does that give you? 8. Very good. So 2 times 2 is 4, and then 4 times 2, or double 2, gives you 8. Now again, if this logical part is challenging, draw it. Draw it out. And if you actually draw it out, it makes a lot of sense here. You get H, T, H, T, H, T. And even if you're looking at this diagram and you still don't get it, you can actually write out all the possible options to get a sense of it. Over time, you'll pick up on how the tree diagram is helpful. So you can get H, H, H. That's one option. You can get H, H, T. You can get H, T, H. You can get H, T, T. You can get T, H, H. You can get T, H, T, 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 H, and then T, T, T. If you count them all, yes, it is 8. So in the worst case scenario, as long as you draw it out, you can still figure out the 8. I'm trying to teach you a quicker, logical way to get to the point to realize it was just 2 by 2 by 2. Because for every option, you get an extra 2. Let me test your understanding now. This is a bit separate from it. What if I flipped a coin? So I flip a coin once, and then I rolled a dice. So that's 2 steps. How many options in total can I get? 12. Very good. So if you think about it on a logical sense, H, tails, so 2 options. But for every option afterwards, when I roll a dice, there's 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what you're really doing is for every option, you got 6 by those numbers. So 6 by 2. 6 times 2 gives you 12. Yeah? So this is why I'm trying to teach you that no matter what the scenario is, the tree diagram will visualize it for you, but you don't have to draw it to know it. You can actually think about it, and you'll be able to figure out the total options. Why do you want to know the total options? Because that's how you figure out your probability. You need to know the total, then what you want out of your total. Yeah? So the challenge is to figure out the total first. All right, now that we've got the diagram and you've got the options there, it's easier to answer the questions. Had I not drawn that, and I just said this to you, I said, find the probability of getting 3 tails. Some of you might have figured it out, some of you might not. There'll be a group of you. But right now, if I asked you, what's the probability of getting tails, tails, and tails? What would the answer be? 1 out of 8, because we said there were 8 options. But how many of those options will have a tail, tail, tail? There's only 1. It's 1 out of 8. I can make the question a bit harder. If you didn't have a diagram, some of you may answer it, some of you may not. But what if I changed the problem to make it harder? What if I asked you, what's the probability of getting at least 1 tails? See, at least 1 tails means you can get 1 tails, 2 tails, 3 tails, or you get tails, tails, heads, or you get tails, heads, heads. How many options are there? Is it 2? to get at least one tail, because I could get a HTH as well. That's one tail. I can also get HHT. That's one tail. So how many has at least one tail? Now, see, this is what I mean. The benefit of drawing a tree diagram, or the benefit of listing out your options. Let's have a look at the tree diagram. Anywhere that has a T, we accept. This has a T, we accept. This has a T, we accept. We accept, we accept, we accept, we accept, we accept. So which one have I not accepted? Because we said at least one T. So there must be one option that has no T's at all. Which one's that? Yeah. And that's what I mean on a logical sense. If you spent time counting this, this would have been the longest way. But if you did it the reverse, it's actually easier. Instead of saying at least one T, why don't we ask, what's the chances of not getting a T at all? Because it's the opposite of that. It means the same thing, yeah? Chance of getting at least one T is the same thing as saying finding the chances of not getting a T, yeah? So not getting a T, we can clearly see there's one. Since there's 8 of them, then a -1, that gives you, there are 7 options out of the 8 that will have at least one T. But the diagram helped. See, if I had not drawn the diagram, some of you might have been trying to visualize or think about it. It's hard. And if it's hard, most of us quit. Because that's the point. When it gets too much thinking, you quit. Yeah? So the tool is to help you not quit and find a strategy to solve the problem. So the answer for this one would be probability of at least one T. So T is greater than or equal to 1. That's a way to write it. So saying tails greater than or equal to 1. You don't want just 2. You don't want just 1. You want more than 1. So we say T is greater than or equal to 1. The probability is out of 8. There were 7 options out of the 8 that were actually going to give you at least one T. So far, so good? All right. I'm going to stop there. That's the exercise for 8I. Okay. Jay will be doing on Thursday for the notes, but that's it for today. So on Wednesday, you will have your time to work on any of the exercises. So G was just learning how to read sample space. H is 2 experiments, like rolling a dice and flipping a coin. And then this one is when you go into 3. You go to 3 experiments. What happens then? How do you visualize it? So that was on the readiness task. Now, most of you didn't know how to do it. Hopefully now you've got a direction and you feel a bit better about it. But practice on Wednesday. All right, you got about 15 minutes left. This is your time to have a think about what you need to do. If you haven't done your checkpoints, your learning task, please check your learning task for your mastery, your progress, and your readiness. Have you updated them? Because end of next week is June. Whatever you don't type there, it's going to get pulled into your semester reports. For tree diagrams, 8I, what we just did today. For tree diagrams.